There we go. All right, so today I'm going to be covering the Roman numerals challenge in JavaScript. Let's take a look at the requirements for that. So this has two parts, the lazy Roman numerals and the modern Roman numerals. I'm going to just do the modern Roman numerals to get that done, because if we can do modern Roman numerals, we can do the lazy one kind. So let's take a look at the actual instructions. So given a number in today's numbers, Arabic numerals, returns equivalent in Roman numerals. So if a smaller number appears before a larger number, you must subtract the smaller one. So they have a list here. So 4 is IV, 9 is IX, 14 would be XIV, etc. And so they have some sample output here. And it gives us a big hint. Consider the data structures that can be used to store numerical values and how it can relate to string representations. And we don't need to concern ourselves with anything over 1,000. So I'm going to just put that in here just so we have that written down in our file. So it was write a program that converts a Arabic numeral to a Roman numeral. That's our first step. Now let's consider that hint for a moment, talking about the kind of data structure that can be used to store numerical values that relate to a string representation. Because we need to turn a number into letters, essentially. So what type of data structure might be useful for this?
An object?
An object, yeah. And could you briefly kind of tell me what does an object do?
So an object can store a bunch of key and value pairs. So basically, like you could make a key, for example, that's I, and then the value for that could be 1, and that's how you could kind of map the values to the different letters of Roman numerals.
Mm-hmm. Exactly. So I can make call this, const. We can call this Roman to Arabic. You always define an object by using those braces. And let's take a look here at our things. So here's our numerals that we have to work with: I, V, X, L, C, D, and M. So the first thing I want to consider is, all right, in what order do I want to store these? Do I want to store it from least to greatest or greatest to least? Or does it matter?
It doesn't matter.
I guess you would start with the largest number.
Mm-hmm. And why is that?
So that way, when you go to pull out the stack, it's just the first one, mm-hmm. instead of having to iterate through like 10 before you get to the one that works.
Yeah, because we do know, we haven't really worked out how we're going to convert the number yet, but we do know it's better to start at the top of the number, figure out what the largest decimal is, essentially, and then work our way down. So we can start this by just doing M is 1,000. Let's see here, then D is 500. One day I'll memorize this, but it won't be today. Then C is 100. L is 50. X is 10. V is 5. And I is 1. All right, so that's our conversion chart. And this will allow us to do it the lazy way. But like I said, I don't want to do the lazy way. I want to do it the modern way, which means I need to make sure that if I get to a large number before a small one, a smaller number before a large one, subtracting the smaller one. So 4 should be IV, for example. So what kind of solution did y'all figure out to, for these other things? I'm going to indent this all a little more. There we go.
Well, we added more entries to the object, like 4 and 9, 40, 90.
Yeah. that is the simplest way to do it, is to hard code in those examples, because there aren't that many of them, right? I believe the only ones we'll need to add are 900, 400, 90, 90, 40, 9, and 4. So we can just edit those in pretty simply. So this would be CM would be 900. CD, whoop, CD would be 400. XC would be 90. XL is 40. IX is 9. And IV is 4. All right, so that has all of our combinations of numerals that we'll need to use, since we're not going over 1,000 really. All right, so now the next question is, all right, we have our object that stores all of these. Before we move forward, what questions do you have about objects and the way we're storing all of these values?
I guess a question I have is, would it work the same way if you stored them with the number and then the letter, where 1,000 equals a string of M?
We can try that out. So in the terminal, I'm going to type in node. That opens up a JavaScript kind of emulator we can use, not emulator. So I can create an object just to see what happens. So I could say let obj equal, and I could say 1 should store the value of I. Let's see if it lets us do that. If I type in obj, so we can see here that we do have a key called 1. If I can do obj 1 like this, let's see what happens. So it does pull it up. So we can do that, but I think the issue here might be if I do obj.keys, I believe. Nope. Is it with this? Well, as you can, all right, I'm not sure, I forget how to pull that up, but as you can see here, it's not stored as an integer anymore because we have those quotation marks, right? So it's automatically converted to a string when we do that. And it looks like that I can access it by the number. So maybe it wouldn't give me an issue, but maybe it would. So you always got to be careful, because like 8 errors out of 10 that I find are always being the data type that I expect to be working with is not what I think it is. That I am working with is not what I expect it to be, that is. So I think in this particular case, it would work fine. But again, just you want to be cautious whenever you do stuff like that, because sometimes it'll convert it into something you don't expect. Good question, though.
I actually wanted to verify with this object. I Googled the amount of Roman numerals, and apparently there is only 7. So when it comes to something as such a finite case as this, it is okay to hard code all the possibilities?
Yeah.
Okay.
Because in this case, I think that the alternative would be to come up with some kind of code that says, all right, if it's equal to this minus, 1 or 10 or 100, depending on the level, and that just gives you a whole lot more issues than it would otherwise.
That's what I was trying to do, and then when I Googled it, I was like, wait, all right.
Yeah.
Yeah, we did that on our solution, and I think after the fact realized it was such a finite situation that the algebra required wasn't necessarily worth the output.
Yeah, I think that's one of the best lessons you can get out of this challenge, is sometimes the simplest solution is in fact the best one. Sometimes you don't need to, come up with a very fancy algorithm. You can just type it in and save it somewhere.
Thank you.
No problem. All right, but now we need to figure out, okay, we get a number and we need to convert it from that into these letters. So let's break that down into steps. So what's the first thing we're going to need when we when we do this.
A placeholder for the answer.
Yeah. We'll need a placeholder for the answer, which would probably be an empty string, right? So we could say, have a variable called Roman numeral, and that's just an empty string. So we know that's where we're going to put all of our what's the word I'm thinking of? All of our numerals. All right. Now we need to figure out, okay, we've got a number. We need to figure out which numerals are a part of that, right? And earlier we decided to store these from greatest to least. Because, all right, let's say my number is, let's say, for example, my number is 94. I'd have to figure out, okay, I have two numbers here, right? 90 and 4. What's the one I should figure out first?
90.
Yeah. And to get to 90, we might want to say something like, okay, we can make our way down the list and say, or down the object, I should say. All right, 1,000, not relevant. 900, not relevant. 500, 400, 100, 90. So that way we can find 90. If we can find 90, then we can add it here. So I could loop through this. So I could say we can call this numeral in our Arabic to Roman, or Roman to Arabic. And before we do that, we want to figure out, wait a second, what is numeral? Or you should probably say for let numeral. So what is numeral in every iteration of this loop?
It represents the Roman numerals as you're going down, just iterating through those.
Yeah, so when you loop through a object like this counter always represents the key in that. So I can demonstrate, so I can console.log numeral. And if I then run my Roman numerals spec, I think I need to, cd into JS, then run node Roman numerals spec. So numeral here every time goes M, C, M, D, C, D, C, etc., all the way to the bottom. All right, so now we know what numeral is. So next we need to figure out, okay, we need to get to the number that key is pointing to, right? So how would we do that? How do you access a value from an object?
You can use brackets or dot notation.
Yes, you can use brackets or dot notation. In this case, we're going to have to use the brackets because if I try to do object.numeral, it'll look for a key called numeral, and we don't have that. So we can say something like, all right, so what can we call this variable? Arabic num equal Roman to Arabic numeral. So if we pass it in M, we should get 1,000 and save it to this variable. All right, then how do we determine whether or not that number is relevant to the number we're trying to convert?
You gotta divide it.
I'm sorry? I heard a few people talk at once, so I didn't hear.
I said you're gonna want to divide your number by. Is that what you're asking?
Well, I'm asking how do we know whether or not the number is relevant, and you said divide the number, but which number by what?
The number passed in by the Roman numeral value, the value of the key.
So we'd want to divide num, which is our argument, divided by Arabic num?
Yeah.
Yeah, but we want integer division, and we're gonna have to take the floor of that. Otherwise, we're gonna get a float.
Yeah, so we're using math.floor, which rounds it down. So we could say, let divisor. And what is that? What will this tell us if we divide? What are we looking for?
How many whole times that number goes into our number?
Yeah, so how many whole times that number goes into our number? So we look at our example here, 94. If we divide 1,000 by 94, we should get a pretty big number. Or sorry, never mind. We're dividing 94 by 1,000, right? And let's see what that rounds out to using node. So if I do math.floor, 1,000 divided by 94, I get 10. But I want to do it the other way around. Every time, 94 divided by 1,000. So that gives us 0. So if this number that comes out turns to 0, that means we're not going to get it in. All right, but if it's greater than 0, what does that tell us? If it's 1 or 2 or 3 or greater, what does that tell us?
That we need to start building a string, and for each whole time it goes into that number, we need to append that string with the correct Roman numeral.
Yeah. So if there are, so essentially if we put in, we tried to do 300, which would be CCC, and we got here and we divide 300 by 100 and get 3, that means we know we need to add 3 C's to our Roman numeral. So let's revise this to call it times repeated, because this will tell us how many times that a numeral should go into our final product. What questions do you have about kind of how we got to this point?
The math.floor num divided by Arabic num, is that the same thing as modulus?
Not quite. So modulus gives you the remainder when you divide. So again, using just going node here, if I do, let's say 1,000 modulus 94, that gives me 60, because essentially when you divide 1,000 by 94, you get 60 left over. Math.floor, all it does is saying round something down. So I could just give it 4.56. It rounds it down to 4 for us. Does that answer the question?
Yeah, thanks.
No problem. And if you wanted to round up, it would just be math.ceiling, I believe, or ceil, C-E-I-L, something like that. All right, so now we have times repeated here, saying, okay, here's how many times that our numeral needs to go into our Roman numeral variable here. Now, how do we get it in there that many times? There's a few ways we could do this.
We did a for loop with the number of times repeated.
I'm sorry, could you repeat that?
We did a for loop with the number of times repeated, and added the string to our output string.
Yeah, we can definitely do that. So we could say for let I equal 0, I is less than times repeated, I plus plus. And then we could say Roman numeral plus equals our numeral, right? So at the end of that, I should be able to console.log our Roman numeral, and it should be changed. So what I'm going to do is I'm actually going to what's the word? Comment these two options out, because for now I just want to see if we can get 3 there. So I'm going to run our spec file. So I did get I here, which is what I wanted after that for loop went. It's still returned as false because we didn't actually return anything with our function yet. But it looks like this more or less works. So that works for that. So for a number like 3, that works out fine, right? In fact, if we just said return, we actually want that, put that after our for loop here, return our Roman numeral at the end, do you think we'd pass our tests? Let's find out. Well, we passed one test. Let's let's make sure we get the others done. So we passed 2 of them. This method works fine for 2 of these, but not for 4. So what am I missing here?
Changing your num to your remainder from the previous division.
Mm-hmm. Yeah, so the more complicated numbers, like 94, for example, aren't going to work very well with this method as it is, because we're not changing our num. It's always going to assume that we're looking at the same number every time. The whole point is that we're stripping away the number by saying, okay, we found how many 90s we need, or how many 100s we need. The next step is figuring out, okay, how many 10s, 50s, etc. So every time we repeat, what do we want to do after that? We want to
subtract.
Mm-hmm.
Yeah, sorry.
So we're going to subtract num from, we're going to subtract Arabic num from num here. So for example 94, we subtract 90, then we subtract 4, and that'll leave us with 0. So once num reaches 0, then it should be working. So let's test our code again. All right, so that works for 1, 3, and 4. Let's add a few more examples just to be sure, though. So we could say, again, using 94, we expect that to be XCIV. How about, what's another example we can use to make sure that our code is as robust as we hope it is?
1, 2, 3, 4.
So 1,234. So that should be CC XXXIV. Does that look right to everyone? Because Roman numerals aren't my specialty.
I think so.
Okay, let's try it out again. So we got 5 trues. So it looks like we've got a working program. So what questions do you have about this solution? It's all making sense on what's actually happening here step by step. Because I want to make sure this is as clear as possible. So if there's any point where it's not making sense, please let me know. Because if I'm not explaining it correctly to you, then that's not very helpful to either of us.
had a question about the string construction.
Yeah.
Is there a way, like in Python, you can kind of do like a multiplication to do like if you needed 3 m's, you could do 3 times m to add that string. Is there a way to do that in JavaScript?
Good question. So he was asking, so in Python, for example, you could do I times 3, and that gives you I. I've forgotten how to leave the Python interpreter. There we go. But in JavaScript, if I tried to do that, I times 3, I get not a number, NaN. So let's Google that. So we could say JavaScript multiply string. See, I've looked up this before, in fact. And if I look at the documentation here, we've got something called string.prototype.repeat. We can take a look at that method. So here, the repeat method constructs and returns a new string, which contains the specified numbers of copies of the string in which it was called concatenated together. So they have something called chorus, because I'm happy. And they console.log it, chorus.repeat 27. It says because I'm happy, because I'm happy, because I'm happy 27 times. So it looks like this method would allow us to do it the same way. So we could say, if I comment this out, I could say it would be, Roman numeral plus equals numeral dot repeat times repeated. And then we need to make sure our number gets still gets put down, subtracted the same amount. So maybe we could say num minus equals, that we'd want to say, it would be times repeated times our Arabic num. So if I try this out, let's see if it still works. So this method works just as well. Repeat is essentially doing the same thing that we're doing here with the for loop. So I don't know if this would be any better in terms of performance, but it is better in terms of number of lines written, which for some people is more important than others. But that's a good question. In general, you're going to find that many times when you use a for loop, or to do something like this, there may be a method that does that for you. I'm not saying you shouldn't do the for loop. I'm saying do the for loop and then check if there's a method that could do that better. Because you'll be surprised how often it'll be like, oh, wait, there's something that does that better, but now you know how it works. Because one problem I get with many programmers will find is they don't like how much magic there is in terms of a method works, but they don't understand how. So constructing it yourself is always a great step, because it's like, if you want to be a mechanic, you got to take apart a car engine, right? All right. Any other questions about Roman numerals? All right, one other thing I'm going to say is, again, so you notice that from going forward, we're always going to have these spec files, or most of the time we're going to have these spec files attached to challenges. We're going to go over writing your own tests later. I think that's next week or later this week. For now, though, it's always a good idea to expand on these tests if it makes sense, because testing 1, 3, and 4 is very, very basic. But making sure that you have robust testing, that your testing covers multiple edge cases, is always going to be good practice, no matter what. So there are kind of more efficient ways to write tests, but for now, console.logging or printing something and making sure the two things are equal or not equal is a great way to test your code out. All right, so I'm going to stop the recording. Let's take a, let's see, what time is it now? 9:07.